Good morning, Algebra 1 class. Today and over the next couple days, we're going to work on linear models and fitting lines or linear equations to scatterplot data. Take a look at these learning targets. Okay, on this slide, I want you to take a look at the graph provided in the equation, and I want you to write down one thing you notice and one thing you wonder. Pause it here. Okay, so some of the things you might have noticed would be the more people there are, the higher the maximum noise level. Or maybe right here at 65,000 people, looks like there's 3 different noise levels. That's kind of strange. Also, we were given the equation of a line. How does this equation compare to the dots or the points and to the line? All right, now for some things you might have wondered. Do you notice that there's no 0, 0? Do you notice that there's no Y-intercept? They did not extend that. Could you calculate the slope of this line? How does that compare to this? And so what? What does this tell us? How can we use this data? Those are some of the things we're going to answer in today's lesson. Some of the vocabulary to look out for today is what is a scatter plot? What is a linear model? How to find the slope of a line? And what is the vertical or Y-intercept? Okay, for this activity, Orange You Glad We're Boxing Fruit, you're going to have to pause this video quite a bit, do some work in Desmos and watch another video, and then unpause here. The first thing I need you to do is pause the video now and watch the other video in the Google Classroom and record the weight for the number of oranges in the box. For the number of oranges, record the weight. Take a look at this table. That's what you want to fill out, this table here. All right, pause it now. All right, so now you should have a table with the weight in kilograms of the number of oranges. Hopefully this is written down on your piece of paper. What you're going to do now is pause the video and plot these ordered pairs on this coordinate plane. Pause it now. All right, so now you can see my scatter plot. What we're going to do now is try to draw the best line we can through the scatter plot or the data points so that it fits the data well. So I'm going to try to do that now. So I think I'll start here. Now, you want to make it a straight line. You don't want to make it curvy, connecting point to point, because the linear model is going to be a line and not a bunch of lines. Okay, make sure you have this written down on your piece of paper. On the next slide, we're going to use Desmos. All right, so what you need to do is open the initial Desmos file. Note that this file, there's 2 out there in your Google Classroom. This file has this code, and you want to open this one first. Once you do that, you want to enter the table data that you wrote down. Just type it all right in. Then you can adjust the window settings as needed to see all of the scattered data, kind of pinch it in and pinch it out. And then you're going to see a line with 2 movable points. Try to move those points to reposition the line through the scatter points so that it fits the data well. Once you're done with that, you're going to pause this video and try to answer questions 4 through 9. Pause the video now, work through that on Desmos, and then answer the questions. And then when you unpause it, you'll see I've written answers and are describing each question. Okay, here are some answers. Let's look at each one. So for number 4, you had to estimate a value for the slope of the line. I estimated 0.2 kilograms. What I did was calculate the slope. I picked 2 points close to the line, 0.4 oranges with a weight of 1.162 and 7 oranges with a weight of 1.761. And then, of course, you take y1 minus y2 divided by x1 minus x2. So it's your change in the y divided by your change in the x. And this represents the approximate weight per 1 orange is 0.2 kilograms. Okay, then it says estimate the weight of a box containing 11 oranges. So we had a chart with 10 oranges. So I took the weight of the 10 oranges, and it's only one more, and I added 0.2, and I got 2.8 kilograms. You can also do this if you have an equation of the line by plugging in 11 for x in your linear equation or model. For number 6, we have to estimate the weight of a box containing 50 oranges. This is a lot bigger estimate. And this estimate, I took the 10, the weight of 10, and I added for each orange 40 more, 0.2 kilograms, ending up with a total of 10.6 kilograms. Which of these two estimates do you think is better or more accurate? Well, being only one value away from the actual data, this estimate is probably a lot better than this estimate. Okay, number 7. You want to estimate the coordinate for the Y-intercept. So what I wanted to do here is take my either the Desmos linear equation or my hand-drawn scatter plot and extend the line back so that it intersects the y-axis. And it looks like it's anywhere from 0.3 to 0.5 kilograms. What this represents is when there is no oranges, what the weight of the box is. So it must be how much the box weighs. All right, for 8 and 9, which points are best fit or least fit by your linear model? I just picked points that was really close to my line and really far from my line. That's it. Feel free to pause or go back if any of this was too fast. This slide shows you what the final Desmos calculator shows. So note here, it's a different calculator code, and feel free to pull this up. You can look at the equation of the line if you open the controls, and you'll see what the slope is and the y-intercept is. There's all sorts of stuff in there, but that way you can look there. Feel free to also go through the directions. For this linear equation, my Desmos showed y equals, I'll write it down, y equals 0.216x, so that's your slope, plus 0.345, so that's your y-intercept. This is in the mx plus b form. All right, for this activity, 4.3 food markup, this is going to get you to test what you know so far. Pause the video here, answer the 4 questions, and when you unpause it, I will go over the answers. All right, here are your answers. So for number 1, what you can do is go to a cost of $1.50 and then find the line, and you can see it's at $6. That's why I wrote $6. You can also use your equation up here and plug in $1.50 and you'll get $5.98. Both of those are pretty close answers. For number 2, it's the same kind of idea, but they're saying it has a sale price of $7. So if I go to my sales price of $7 and go over to my line, I can see it's between 1.5 and 2. So it's about $1.80. Or I can plug 7 in for y of the equation, minus the 0.76, and then divide by the 3.48, and you get an x, or an ingredients cost, of $1.79. Anywhere close to those is fine. For the slope of the linear model, it's $3.48. I just took it from the equation. What this means is for every dollar increase in ingredient cost, the sales price goes up by $3.48. Lastly, what is the y-intercept? So right here, you can see it's just less than $1. But if I go to my equation, it's 0.76, which means that if the ingredient cost was no dollars, they could still sell the item for 76 cents. What does this mean, or does this make sense? It clearly doesn't make sense. If they have nothing in the item, they shouldn't be able to sell it for 76 cents. For this next slide, you want to identify the slope for each model and what it means in words, as well as extend the line and find the y-intercept for each model and explain what it means in words. Write down your answers, and then I will go over that. All right, for A, the slope is negative 0.25, which means for each additional age or year, the reaction time goes down by negative 9.25 milliseconds. The y-intercept is 400, which means for someone of 0 age, their reaction time is 400 milliseconds. Doesn't make a lot of sense. All right, in B, the slope is 0.44, which means for every additional banana, the price goes up 0.44 cents, which means the cost of a banana is about 44 cents. The y-intercept says 0.04. It's probably really 0. If you have no bananas, it should cost no dollars. Go ahead and try to do the same thing on these two models, models C and D. Pause it here. Okay, your answers are as follows. For model C, the slope is 4 and the y-intercept is 87. The slope means for each 1 foot more in square foot on the room size, the cost to install flooring goes up $4. And the y-intercept says if the room size is 0 square feet, the cost to install flooring is $87. A lot of times the y-intercept does not make sense. Okay, model D. Here, the slope is negative 2.4 and the y-intercept is 25. The slope means for each 1 degree Celsius increase in temperature, the volume or cubic centimeters of whatever it is goes down 2.4, so it goes down, because it's going down, 2.4 cubic centimeters. And the y-intercept says if the temperature is 0 degrees Celsius, then the volume is 25 cubic centimeters. This probably does make sense, and you can see if we extend it, it should be up there around 25. All right, for the next 3 pages, it's 3 questions. Are you ready for more? Pause when you get to the page, answer it, and then unpause to see my answer. Okay, so the slope of this is negative 9 divided by 1,000, which means the fuel economy decreases 9 miles per gallon, so that's your numerator, for each additional 1,000 kilograms in mass or weight. So remember, X is the car's mass, that's your part here, and Y is your fuel economy. All right, so what's the y-intercept? The y-intercept is 34.3, which means a used car, because that's what it was, used cars, gets 34.3 miles per gallon if X is 0, or the mass of the car is 0. Kind of interesting. All right, next slide. Read this over and pause the video. Okay, the answer is yes. We can see that as mass increases, that's your X variable, the fuel economy is going down. So his claim that the fuel economy of new cars decreases as mass increases is correct. Next slide. Read this over and pause it and write down your answer. All right, so Elena claims that the fuel economy decreases as the mass increases. So take a look at our data. Here, the mass is getting bigger, and here the fuel economy is going down. So she is right. As mass gets bigger, fuel economy decreases. So that's correct. Now, how could Elena compare the decrease in fuel economy as mass increases for new cars? Note, this chart is for hybrid cars. So we could calculate the slope for this chart, and it would be something negative because it's decreasing. Fuel economy is going down. And then we could compare that to Diego's data, where he was looking at new cars and their economy and mass. And then look at both slopes, look at who's decreasing faster, and stuff like that. So it would be great to have both scatter plots or both sets of data and a linear model for each of them. All right, so I know this video is quite long. This is your last practice problem. Go ahead, pause the video, try it on your own, write down your answers. Do that now. All right, here are your answers. So the slope of the linear model is 1.5. We can see that in the equation here. What does this mean? It means that for each additional 1,000 people, the noise level increases 1.5 decibels. It's increasing because this is a positive slope. For number 2, the sports announcer states that there are 65,000 fans in the stadium. So if I go to 65,000, I can go up to my linear model, and then I can go back and see what the maximum noise level is. It's approximately 120 decibels. Note, you can also plug 65 in the equation. You don't want to put in 65,000, just 65, because they're representing the 1,000 with the 65. Last question says, what is the Y-intercept? And you really want to take this from the equation. It's 22.7, which means for an empty stadium, no people, the maximum noise level is 22.7 decibels. Now, if I go to the graph and I extend the line, it certainly doesn't look like it's at 22.7. Be careful. This is not 0, 0. Note, if this is at 60 and this space is 5, this is only 55. So this graph, it's hard to use the extension sometimes with the scales that you have. So just be careful and go to the equation or linear model if you have it. That's it for today's lesson. Hopefully you were able to pause and restart the video throughout each slide. Please ask your questions on the Google Classroom or in our next Google Meet. Bye.